Hey guys, Mr. Yaisley here. So in this next part of the notes, we're going to talk about solving special case examples. And so special case examples, as you learned about in your vocabulary, deal with infinite solutions, also can be known as all real numbers, or no solution as well. And so those are typically what we mean by special case. If you end up with x equals 5, that's a normal solution, and so it's not considered a special case. However, how we solve special case examples, or equations, is really no different than what we did when we solved regular equations. We're going to go through the exact same steps. We're going to go through those three pre-solving steps of parentheses, like terms on one side of the equal sign or the other, variables on both sides of the equal sign, and then we'll get into our two-step equations and our to-do-undo. All of that will be the exact same. So how you go about solving these is really no different. Now, when we get down to the end is where we're going to identify if this is a special case or not, and I'll show you how to identify that. So let's start with example A. So example A says 3 times 5x plus 2, all in parentheses, is equal to 15x. So first thing I notice, hey, right off the bat, we've got some parentheses. So we're going to clear those like normal using distribution, also known as multiplication. So I'm going to multiply 3 times 5x, which is 15x. I'm going to multiply 3 times positive 2, which is positive 6. And then I'm going to bring down everything I didn't use, which is the equal sign and the 15x. Second thing I'm going to look for is like terms on one side of the equal sign. So I've got 15x and positive 6. Those are not like terms. The right side only has one term, so no like terms there. So don't have to do anything with that step. Third step I'm looking for, do I have variables on both sides of the equal sign? Well, I see that I have a 15x here and a 15x here. So I do have that. So as before, we're going to move them to one side or the other. Now, as we talked about before as well, we want to move them to the side that doesn't have the number with it, because that's going to simplify that. And we move it through addition or subtraction. So if it's a positive 15x, we're going to move it through subtraction. So I'm going to move this one all the way to that side, and I'm going to do it through subtraction. So minus 15x. And then I got to do it to the other side, minus 15x. Well, when I do that, I notice that that causes this to cancel, and it causes this to cancel. So I'm going to bring down what I have left, which is 6 on this side, my equal sign. But what's left on that side? Well, nothing. And the way we say nothing in math is 0. Well, anytime that happens, guys, and you end up with just two numbers, if those two numbers are not equal to each other, that's known as a no solution. Well, does 6 equal 0? No, it doesn't. That does not equal 0, so that means this is a no solution, which really just means that there is not a number out there that we could use, fraction, any sort of number, that will solve this and make this equation true. So that's how we identify no solution, is if we end up with two numbers and it is not the exact same number on both sides, then it is a no solution. All right, let's move on to example B. So we're going to start as we did before, see parentheses on that left side of negative 2 times 4y plus 1, all in parentheses. So I need to clear those. Going to do that through my distribution. So negative 2 times 4y is negative 8y. And then negative 2 times positive 1 is negative 2 equals negative 8y minus 2. All right, well, you may be looking at this going, those are the exact same on both sides. They're exactly the same, and that is true. And as we get further into our mathematical skills, as soon as you get to there, you'll know what the solution is. But I'm going to work this a little farther just to show you what I mean. So now I would move on to have like terms on one side of the equal sign or the other. Nothing on the left side, nothing on the right side that's like. So move on to I have variables on both sides. Yes, I do. I have a negative 8y and a negative 8y. Well, I need to move them to one side or the other. it really doesn't matter because they're the same. So to get rid of negative 8y, I'm going to add 8y, which means I need to add 8y. Well, when I do that, that causes those to cancel. It also causes those to cancel. And all I'm left with is negative 2 equals negative 2. Well, as we said before, if we end up with just two numbers, one on each side, and those numbers are equal to each other, that's known as infinite solutions. If I could spell, there we go, infinite solutions. Or you can say all real numbers. Either one of those is an acceptable answer. You can't just leave it as negative 2 equals negative 2. That's the solving, but you need to have the solution, which is one of these two, infinite solutions or all real numbers. It's not infinity. You can't put an infinity sign because that's not what that means. All right, it's infinite solutions, meaning any number we put in, whether positive or negative, will work to solve this, or all real numbers, and real numbers are numbers that are both positive and negative, so both of those work. Now, in terms of what we want to see on these ones, if you get down to negative 8y minus 2 equals negative 8y minus 2, and you recognize those are the exact same, you can just write infinite solutions or all real numbers right there at that point, and I'm okay with that. All right, if you prefer to go ahead and get rid of the variables and get it down to just the two numbers to make sure that they are the same, you can do that as well. All right, but at minimum, you would have had to get to negative 8y minus 2 equals negative 8y minus 2. All right, well, example C, I would encourage you to try that one on your own. So pause it, try it out, and then unpause the video and check your work with us. All right, well, first thing I'm going to check for parentheses. Do I have that? Yes, I do. So I'm going to clear those. 4 times 1 is 4. 4 times negative x, because remember I got to include this right here, is negative 4x equals negative 4x plus 4. Well, at this point, I don't see that they are the exact same on each side. So I'm going to go ahead and move on to the next step and say, do I have any like terms on one side? No like terms on the left side, no like terms on the right side. So third step, do I have variables on both sides? Well, yes, I do. I have a negative 4x here and a negative 4x here, so I need to move them one way. Well, I'm going to go ahead and do that. So I'm going to add 4x and I'm going to add 4x. Well, when I do that, that causes the x's on both sides to go away, and all I'm left with is 4 equals 4. Well, again, those are the exact same numbers, so that means that it is a infinite solutions, or all real numbers. Now, earlier I said that they didn't look the same. When I got to this point, I had 4 minus 4x equals negative 4x plus 4. Well, if I rearranged my equation on one side or the other, that would have given me the same thing. If I had turned this and I said negative 4x plus 4, that would have been the same. So that's why we ended up with the exact same number on both sides, even though they don't look identical. So in that case, again, you could have stopped right there if we saw that they were identical. If you didn't notice that and you took it to the numbers, that's okay too. But again, with special case examples, I think it's always helpful to take it all the way down to the numbers so that you can figure out, are the numbers equal to each other? If they're not equal to each other, that means it's a no solution. If they are equal to each other, that means it's an infinite solutions or all real numbers.